Let's revise in brief some problems of application of integration. Now, to solve problems, you should know basic equations. This is the equation of a circle, okay, where h and k are the coordinates of the center. R is the radius, and usually we are given the radius in r square, so you have to identify what exactly is r. Now if the circle is centered at the origin, then directly the equation of the circle becomes this. Okay, so remember that if this is the case, then the circle is centered at the origin. If not, then this is the h and the k will be your origin, will be your center of the circle. Now equation of parabola is y square is equal to 4ac will look like this. Okay, and y square is equal to minus 4ax will look like this on the negative x-axis, whereas x square will be above and x square minus 4ay will be below. How to remember is y square is equal to 4ax. Here x is there and x is like this. Okay, so it is on the x-axis. Okay, if it is positive, here there is positive, so positive side, and x is negative here, so negative side. But x square is equal to 4ay, so it is upward or downward, okay, depending on the side. Now equation of ellipse, it's this: x square upon a square plus y square upon b square. If the a square is greater than the b square, then the ellipse is on the x-axis, okay, major axis, and the end points of this ellipse, they are called the vertex. Okay, it is having coordinates a comma 0 and minus a comma 0. If the equation is like this, where your a square is greater and is under y, then you should know the ellipse is drawn major axis on the y axis, and coordinates of the vertex, this point will look like 0 comma a or 0 comma minus a. Next, one problem we will solve. Using integration, find the area bounded by the parabolas 3y square 16x and 4x square 9 is equal to 9y. Now I simplified the equation here and here. Now let us draw it. Drawing the figure is very important step. Okay, as I had said, y square is equal to something x. So it is positive, so it will be on the x-axis. Okay, so this is like this, and the x square is equal to something y is like this and positive, so it is upward. Okay, now you have to find the area bounded by these parabolas. That means this inside these curves. Okay, now before moving ahead, if you are going to integrate from this point to this point, you need to find x here, and x here is known, that is 0. Okay, but we need to confirm it, so we find the point of intersection. So that is an important step. Okay, what I have done is I have squared this equation, original equation of this parabola, okay, and I have come to this step. And now I have something y square already, which is here, okay, that I have substituted. So 81 into 16 by 3 x. Then I've simplified and I have got x raised to 4 is equal to x raised to 4 is equal to 27x. Okay, I've taken the x 27x the other side, taken out one x common, and rest is here. Now this is of the form aq minus bq. Okay, this can be written as a minus b into a square plus ab plus b square. Okay, that is what is done here. Now when you find the roots, you get x equal to 0 and x equal to 3, and the roots from this part are complex roots. Hence, I do not find complex roots. 2 points of intersection is enough for me. So here x is equal to 3. Now the main part is finding the area. Since it is enclosed by two curves, the first curve is y square is equal to 16 by 3x, and the below curve is x square is equal to 9 by 4y. And you remember I have told you required area is area under the upper curve minus area under the lower curve. Okay. So if I'm integrating with respect to x, okay, if I'm integrating with respect to x, I have to convert my equations in terms of x. Or if the actual thing is integral of y dx minus integral of y dx, okay, 0 to 3, 0 to 3. Now upper curve is, what is the upper curve? The upper curve is this part, that is y square is equal to 16 by 3x. So y is equal to what? 4 by root 3 into root x, taking the square root. Okay, so that I have written here, and minus the lower curve, that is x square is equal to 9 by 4y. I changed it, x square into 4 by 9 is equal to y. So I substitute this part in place of y. So 9 by 4 by 9 x square. Yeah, same thing. And now you know to integrate definite integrals. Okay, so that is done, and always write the units. Next problem, find the area of the circle, that is 4x square plus 4y square is equal to 9, which is interior to the parabola x square is equal to 4y. Now this equation I have simplified, and you remember in the beginning we discussed, if it is in this form, the center of the circle is the origin, and the radius is nothing but the square root of 9 by 4, that is 3 by 2. And this is the equation of the parabola. Now let us draw what we have understood. Okay, we have a circle which is centered at the origin, and radius is minus 3 by 4 2 and between 3 by 2. Okay, so this is my circle. I'm interested in the coordinates of the x x-axis because I will integrate along the x coordinate. Now there is a parabola which is x square is equal to 4y. Look at this, it's y, u and it's positive, so the curve is upward. Okay, this is x square is equal to 4y and this is x square plus y square is equal to 9 by 4. Now you have to find the area enclosed by these two curves. But if you look clearly, okay, just because the diagram is crooked, this side and this side are symmetric. So if I find the area of only this part, then I can multiply it with 2 to get the total area of this interior plus this interior. Okay, so that is what we are going to do, but before that we need to find the point of intersection so that we can integrate it properly. Okay, this point and this point. So taken the original equation. Why? Because I can substitute easily. Okay, I have 4x square is there already with me, so instead of that I have put 4y here. Okay, and I have written 4y square as 2y the whole square is equal to 9. Now what I am doing is basically trying to form a perfect square on the left hand side, on this side. So I have 2y square plus 2 into 2y, which is my total 4y, into this 4, okay, original. But to make it a perfect square I have added 16, and if I've added 16 on right, I added 16 on the left also. Okay, so I get this as my perfect square. How do I get? First term plus the second term, which is 4, second term, the whole square. That is 16 plus 9 is 25. Now I've taken the square root, and because I'm going to focus on integrating only in the first quadrant, I know my y will be positive. Okay, so I have considered the positive value of 25, square root of 25, that is 5. So I will get here 2y is equal to 1, okay, and y is equal to half. Now I want to integrate along x-axis, so I do not want to deal with y, so I will put this where? I will put this here. Okay, that's what I have done. I have put x square is equal to 4y. Y is my half, which is 2. So x is equal to plus root 2 and minus root 2. Now I've got both the points. Okay. Now I'm going to focus only on this part, that is from x equal to 0 and x is equal to root 2. Okay. The total area is 2 times this area. So 0 to root 2, upper curve minus lower curve. Okay, this is my upper curve y2 and this is y1. Now my y2 is nothing but the circle, that is x square plus y square is equal to 9 by 4. I have to write in terms of y. So 9 by 4 minus x square. So y is equal to square root of 3 by 2 the whole square minus x square. That is what I have written here. Okay. Now after this, I have to find the lower curve. Lower curve is nothing but x square is equal to 4y. So this is easy. X squared by 4 is equal to y. That is written here. Okay, now look at this integral. This is like integrating integral of root of a square minus x square, whose formula is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. That is here, this whole thing, minus the integral of this is nothing but x cube by 3 into this 1 by 4. Okay, and put the limits and you'll get the answer. That's it.